All right, welcome to the next video. We're talking about linear first order differential equations and the integrating factor technique. So let's start just by saying a linear first order differential equation, okay, is of the form a1x y prime of x plus a0 of x y of x equals some f of x. Okay, so when f of x is non-zero, this is of course non-homogeneous. And these functions, they can be functions, still going to make the equation linear. The linearity, again, refers to the derivative of y and y. Okay, so we can solve most of these pretty directly. All right, let me show you the technique, which is the integrating factor technique. So first we're going to pretend we have the derivative of e to the integral of, let's call it h of x. Let me call it not of x, let's call it of s, or u du, times y of x equals, let's say, let's on the other side, let's call it some capital F of x. Okay, now we're going to integrate both sides. Okay, so if we integrate both sides, we get e to the integral of h of u du y of x equals f of x plus c. So we're going to keep the constant here. Okay, this is just theory, so don't be too stressed out about this yet. I shouldn't say just theory and not be, but you know what I mean. I'm not going to test you on this aspect of it. So e to the negative integral of h of u du. Actually, maybe I am. I don't know. I haven't decided yet. It's still a month and a half before classes start, so we'll see where I decide by then. Okay? But this is going to be our y of x. Okay? Well, that doesn't look anything like what this looks like, does it? Well, not yet. We're actually going to start with this and actually make it look like this. Okay? So let's take this thing and let's see where it goes. Let's just take that side. Okay, if we take that side, we're going to get h of u times e to the integral of h of u du y plus e to the integral of h of u du y prime equals f of x. Okay, so in some essence, this is our first order linear differential equation. This is our a1 of x here, and this is our a0 of x. Okay, so the goal is to consider, so let's say we have, let's start off again with y prime of x plus a0 of x, y of x equals f of x. Okay, so let's assume that we have a situation like this. What we can do is we're actually going to multiply by what's called an integrating factor. Okay, so our integrating factor is going to be let's call it e to the integral a0 of u du. Okay, this is going to be a function. Okay, we're going to multiply the whole thing by that. Okay, so we're going to get e to the integral a0 of u du, and I'm going to put a little x on there to show that really what it is we're taking the antiderivative in x there. Okay, plus, oops, sorry about that, times y prime plus e to the antiderivative a0 of u du y equals e to the integral in x. So we multiply the whole equation by this integrating factor. Okay, now this left-hand side is actually the derivative with respect to x of e to the integral with respect to x, a0 of u du, y, and then the right-hand side is some function of x. And then we're going to follow the procedure that we had way up here. Okay, seems a little confusing, so let's go ahead and get into some examples.